In this next section, we're going to be looking at chemical and physical oceanography, basically the chemical and physical processes of the oceans itself. So as we're looking at this, the question is, what is the most important material in marine biology? And it comes down to one thing: water. The oceans, remember, cover over 70% of the Earth's surface. Also, organisms that live within the oceans, a vast quantity of their makeup is water also. Earth is a unique place in that it has water in all three physical states of matter. Water itself, remember, is made of two hydrogens attached to an oxygen atom. And because of their arrangement and the way they fit together, water is known as a polar molecule. This means that on one side, the oxygen side, it has a slightly negative charge to it. The other side, where the hydrogens are, have a slightly positive side. So there are two opposite charges on there. This allows water to form hydrogen bonds. This is the attraction between the hydrogen atoms of one water molecule and the oxygen atoms of other water molecules that happen to be nearby it. These hydrogen bonds are what holds droplets of water together and can allow you to literally pile up water on top of a flat surface like a penny. The hydrogen bonds are also what gives water many of its unique characteristics. Because water is a polar molecule, it has a high heat capacity. That means that it takes a fair amount of energy to be able to get the water molecules to change states of matter. It can absorb a lot of energy before it will actually start to change. So if we look at this particular graph, if you have solid water and you're adding heat to it, you're increasing the temperature. The temperature is going to be increasing slowly. And when it gets to about 0 degrees Celsius, you're going to be adding in more heat. It's going to be continuing to absorb energy, but the temperature is not really changing. Once most of those hydrogen bonds have been broken, then the water becomes in a liquid form. And so it's going to start to increase in temperature slowly until it gets to about 100 degrees Celsius, where it then spends a lot of the energy absorbing, breaking apart all the hydrogen bonds, and the water turns into a gas. The fact that it has a high heat capacity has a fair amount of significance in the oceans. This means that the oceans tend to maintain a fairly constant temperature. They can absorb a lot of energy without changing temperature. That, in combination with the fact that the oceans are so large, and there's a lot of space for that energy to be distributed. In spite of this, there are things that can affect the temperature of the oceans. Most of these effects are felt locally. Evaporation, for example, as water molecules leave the surface of the ocean and move up into the atmosphere, it actually pulls some of the heat energy along with it, causing the water in the area to cool off. As the sun shines down on the water, it can add energy and cause increases in temperature. The closer to the equator you are, the more direct the sunlight, and so the warmer the water. The further away from the equator, the less direct the sunlight is, and so the cooler the water. As the seasons change, so can the temperature, though usually the temperature changes lag behind what the air temperatures are. So it has to be fairly cold as we head into winter before those water temperatures really start dropping. And then it has to start warming up quite a bit and be warm for a while before the water temperatures come back up in the spring into summertime. On a very small scale, hydrothermal vents and volcanoes underwater can warm the temperature of the water in a localized area. And all of these things can have an impact on organisms found in the oceans. There are some types of organisms that can only live in certain temperature ranges. And so if the temperature is changing, this may affect their ability to live in a particular area. Because water is polar, it also makes it a very good solvent. which is why water in the ocean happens to be salt water. The salts in the water cause the freezing temperature of water to decrease. It means it has to be much colder before the water will start to freeze in the oceans. It also means that the evaporation point is higher, which means the temperatures have to increase more before water starts to evaporate from them. The salts that are found within the oceans can vary. The most common ones are sodium chloride, common salt, but there are others as well, which include calcium, potassium, magnesium, and different sulfates. How much salt is in the water can play an impact on organisms and their ability to function. Certain organisms can control the balance of salts between themselves and the environment, others not so much, and so they're going to be able to withstand much smaller salinity ranges. And salinity is simply a measure of how much salts there are in the water. There's a couple of different units that can be used for salinity. One is called practical salinity units, or PSU. This is accomplished by measuring how well electricity is conducted through the water. The more salt, the greater the conductivity. A much more common way is in a unit called parts per thousand. This is kind of like a percentage, but it's moving the decimal place one more to the right. Regardless of what the actual salinity is, the amount of one salt compared to another within the ocean stays the same. This is the rule of constant proportions. We can look at this visually. Let's say we have two equally sized samples of ocean water. The one on the left has a salinity of 35 parts per thousand. The one on the right has a salinity of 18 parts per thousand. That means the one on the left has a much greater amount of salt in it than the one on the right. However, if we look at how much sodium and chloride and the other types of salts that it may contain, they're going to be in the same basic amounts. About 30% is sodium, 55% is chloride, and the rest makes up the remaining 15%. Some different things that can affect the salinity mostly has to do with the adding or removing of fresh water. Various forms of precipitation can add fresh water to the oceans, causing the salinity to decrease. When it's warm or particularly dry, water is going to be evaporating and leaving behind salts, so that's going to tend to increase the salinity. If it happens to get cold enough, the water within the oceans is going to start to freeze and leave behind salts, increasing it. You're going to typically have a lot of salts added around hydrothermal vents, and the deeper within the oceans you are, typically that's where you're going to find more salts. Now, salinity and temperature also have an effect on the density of the water, not just the organisms. And this density can cause various things to happen within the oceans and in turn affect the organisms that live there. As the temperature goes up and the water molecules start moving around faster, it causes a decrease in the density. As the temperature goes down, the density goes up. The molecules slow down, they get closer together. As the salinity increases, the density increases. As the salinity goes down, the density also goes down. The more dense the water, the easier it is for things to float. Things that are less dense are able to basically sit on top of the water that's there. Different layers can actually form within the ocean because of their density. The least dense layers of water are closest to the surface, and the more dense layers of water are found further down. In order to get a picture of what this looks like, there's a variety of different tools that scientists can use. They typically use what's called an electronic reversing thermometer to be able to measure temperature. That basically means that it's going to record temperatures at specific depths and store them or relay them to a ship. Regular thermometers, if you lower it over the side of the boat, as you pull it back up towards the surface, the temperature is going to change. It's not going to stay at the same temperature. To be able to measure salinity, you have to be able to have a sample of water. One way of being able to do that is with what's called a Niskin bottle. Basically, it's an empty tube that's lowered over the side, and at a certain depth you can trigger it to close and capture a sample from that particular depth. Once you have your sample, you can measure the density of the water using a hydrometer, and this will basically give you the density of the water, and from that you can calculate salinity. You can also measure salinity by how much light bends as it goes through. These are a couple of examples. One's a manual, the one on top, where you actually look in to see how much the light has bent. The one on the bottom is an electronic, and it'll tell you what the salinity is based on how much the light bends as it goes through. Again, salt increases how well electricity moves through it, so you can use a probe to measure how conductive the water is. Now you can lower individual bottles, but that can often take long periods of time. So oftentimes scientists will put these together into racks with electronic devices so they can collect a sample of water, they can take the temperature at a particular depth, and they can also measure its conductivity right in place. Satellites can also be used to determine surface temperatures in the ocean. So what do these ocean layers look like? They're all based on density. And they are fairly distinct layers compared to one another. The closer to the surface you are, the warmer it is. At the very top, you've got the surface layer, which is oftentimes called the mixed layer because of all the movement that occurs there. Below that is the intermediate layer. This is where you have what's called the thermocline. In this intermediate layer, you have a rapid decrease in temperature without changing depth very much. If you look at that surface layer, the temperature stays fairly constant, but as soon as you get into the intermediate layer, temperature decreases very rapidly. And finally, you have the deep layer, where the temperature can decrease as you go down, but it's a fairly slow decline in temperature as you go. Most of the deeper layers are fairly stable. That means that they stay constant over time in terms of salinity and temperature. Closer to the surface, things are a bit more unstable. There are more factors that can affect their density in terms of both salinity and temperature. With those stable layers, they can have what's referred to as a fingerprint. That means they have identifiable characteristics, and as the water moves and flows around the ocean, scientists can actually track these layers. For the unstable layers near the surface, you can have overturning take place. That means if something causes the density of the surface layer to increase significantly, it can actually swap places with a layer beneath it. This can cause oxygen that's near the surface to drop down low, and oxygen depleted water that was lower down in the ocean to be brought towards the surface. This can also cause nutrients to be moved around as well. So it's a very unstable environment, and it can cause problems for organisms living in a particular area.